Nobody wants to admit it. I know. Okay? Why? Too much HHO. Okay? I'm a minimalist. Like I said, a third to half a liter. If I wanted to run my engine on hydrogen, I would do many things differently. Okay? But if you're trying to make your car a hybrid, which is what we're doing, we're making water hybrids. Nice way. Doesn't that sound nice? Water hybrids? Okay. So if you're going to make a water hybrid, okay, then you want to make sure that you're just putting in enough to be able to change the molecular structure of the gasoline and be able to not dramatically affect your O2 sensors. Any questions on that? No? Wow, okay, great. All right, let me go in a little bit about, so our unit was based with a trunk. Why is it based with a trunk? So it has the atmosphere with the atmosphere you live in, more stable temperature, I believe a cleaner installation, and people can open up their back lid and show this nice box. There's a certain amount of bling. Everybody knows that word. There's a certain amount of bling when you mount it in a box, but so far people have been very receptive to it. You know, and like I said, the biggest problem we run into is our installers over and over and over could not find. We were taking the liner of the wheel well out and mounting it in front of the wheels in the wheel wells. They got to be so crazy, you know, and so we just decided to really look at a whole, you know, get out of the box, get out of the hood, and look at other areas, and that's why we started working on this thing. All right, a little bit about the electronics. We started about 6 or 7 months ago, really coming up conceptually, looking at electronics, and many of us have worked together on different electronics projects and saying, okay, we're working the O2 sensors, we're coding. We're working on, okay, oh now it's the map sensor. Oh, we gotta have a map sensor. Oh, no, it's the map sensor, you know? And we're running around you know, with our tail between our legs, trying to chase which sensor is going to be the holy grail for HHO. Has anyone done this? I have. I mean, you know, and we found that it's you know, computers are garbage in and garbage out. Okay, so it's reading a sensor, but it's not one sensor. It's actually 6 or 7 sensors that are getting more and more important. Okay, and you know, some engines have up to 26 sensors. My van has 3 timing sensors. Okay, now how crazy is that? Okay, but understand that there's many sensors. What we have evaluated and feel is important if you're going to control and keep parity inside the engine. Okay, which means the computer does not look at one sensor. Okay, it looks at all the sensors and then it picks a fuel table. Okay, a fuel table is a ratio and averages for that particular time, like barometric pressure. All right, why would that be an important thing for cars? For injection systems. We're talking about an injection system that injects milliseconds worth of fuel. Okay, well, because if you're at sea level, or if you're in Denver, Colorado at 5,000 feet, there's a dramatic difference in fuel table for those 2 areas. So every time you turn on your car, you measure barometric pressure. You know that? You do. Okay? So how can you control that? Well, many times it's built onto the map for map sensors. Okay? But if it's not, it's the first turn on it. So that's why many times you hook up to your map and your map, you have a problem if you just have a little dial unit because you have it set to that little particular place where you have it. But what happens, you turn your car on and 30 seconds later a code comes up. Because your barometric pressure just said that you're 18,000 feet in the air. Okay? That's why it's out of parameters. Okay? Because you adjusted your map or your map and there can't be that setting for the barometric pressure. Okay? It's reading a different table than your map or your map. That's why that code comes up for people. Okay? So when you turn on your car, your system has to be normal. Okay? That means garbage in, garbage out. All your sensors have to be reading what they would normally read. And then the EPA gives basically 5 minutes from that point to be able to ramp up, to be able to actually get to modification. That way your system's warming up, your air temperature, your water temperature's coming up, your fuel is stabilizing. All these things happen within the first 5 minutes of your fuel tables. Okay? So that's what we designed into it. We decided, well, okay, we're going to take parity. We're looking for parity. We're trying to be able to have all these things match up. And so we took, we do your O2 sensors, we do MAP, MAF, air, water, and throttle positioning sensor. Okay? I know it's a lot. All right? Now, why do we do throttle position sensor? Different speeds. Calculated load is based on throttle position sensor. Okay? Calculated load, oh, I'm going down the road and I'm the only person in the car. Oh, I'm pulling a 10,000-pound trailer. Well, guess what? Your foot is a lot farther down your gas pedal when you're pulling a 10,000-pound trailer. Calculated load. Okay? Now, if you have a calculated load of 10,000 pounds, okay, you're going to be burning more fuel, aren't you? Okay? Well, if you have a calculated load, if you're pulling 10,000 pounds and you only are, it tells the car that you're only pulling 3,000 pounds, less fuel. Okay? Now, why do we do air temperature? Air temperature dramatically measures the volume of the air. Remember, we only have 1/3 of oxygen going in the air. I'm not talking about HHO, we're talking about just the engine itself. That 1/3 air is going into the engine, right? Well, if that 1/3 of air is at 0 degrees, it is so dense, you're getting a massive amount of oxygen going into the engine. Or it's 300 degrees, and you're getting very little oxygen into your engine. So because of that, the air temperature dramatically changes your fuel tables. Okay, I find around 220 degrees air temperature on my van. It's about 3 miles to the gallon. Significant. Okay. Water temperature. Again, why is water temperature important? Well, water temperature does a lot of things. Water temperature not only controls fuel tables, it also controls timing. Okay? If you're starting to push the outer limit of your hydrogen and you're over 1 liter a minute and you're finding that you're losing mileage at that point, you can use your air fuel of your water temperature to be able to start to control that. Okay? If an engine's running at 190 degrees,